For decades, the global supply chain relied on a simple model: design in one country, manufacture in another, and ship across oceans. That system is now undergoing a massive structural realignment as production moves back to American soil. A major driver of this change is the 2026 USMCA Joint Review. Trade regulators are pushing for stricter regional value thresholds and the exclusion of Chinese-affiliated capital from the North American supply chain. These new rules have teeth. U.S. Customs has responded with a 20% increase in audits, creating significant operational bottlenecks for manufacturers who still rely on international tool and die transfers. To avoid these logistical risks and potential tariffs, procurement teams are abandoning global networks in favor of domestic hub-and-spoke models that utilize local machine shops. This shift is creating an immediate surge in demand, as specialized tooling and mold projects that were once sent overseas are now being awarded to American shops. But while demand for domestic machining is peaking, the workforce required to meet it is shrinking. This chart illustrates a significant demographic imbalance in U.S. precision machining. Over 31% of the workforce is 55 or older, while the youngest cohort represents only 16%. As these senior workers retire, the industry faces an estimated 34,200 annual vacancies. This creates a loss of tribal knowledge that is particularly acute in aerospace and defense manufacturing. In these sectors, master craftsmen cannot be easily replaced. ITAR security clearances and the years of experience required to work with specialized alloys create a high barrier to entry for new placements. America is losing its most experienced technical personnel at the exact moment global trade pressures require domestic production to scale. To bridge this talent gap, top-tier machine shops are integrating a new layer of technology into their operations: Agentic AI. Unlike standard software, these AI systems act as independent agents that monitor shop floor metrics in real time. They document the specific cutting parameters and tool wear patterns used by senior staff, converting decades of human experience into digital data. These systems can automatically adjust CNC settings and execute complex tooling swaps, maintaining production speeds that would be difficult for human operators to sustain manually. This technology allows the modern machinist to function as a systems architect. By using digital twins, they can simulate an entire machining run virtually to prove out a program before the first cut is even made. This digital infrastructure preserves specialized operational expertise, turning it into a permanent and scalable resource for the shop. As AI manages the data, additive manufacturing is changing the physical requirements of production. The legacy model of part fabrication is slow. A typical 9-month journey involves sourcing steel plates, shipping, manual welding, and final assembly. Large-format additive manufacturing replaces this with a 3-step loop: generative AI design, direct 3D printing, and a minimal CNC finish. Energy technology firms like Baker Hughes have already adopted this hybrid model. They now manufacture complex industrial valve trims entirely in-house, eliminating the need for a multi-month, multi-supplier fabrication chain. Defense contractors use similar generative design software to produce aerospace components that are 30% lighter than those made with traditional machining. By combining 3D printing with precision machining, shops are cutting lead times for critical national security components from 9 months down to just a few days. The need for personnel who can operate these advanced systems has created a significant financial opportunity for a new generation of technical professionals. This heat map shows where the demand is highest. Because of a nationwide bidding war for talent, advanced CNC programmers and master tooling specialists are now earning base salaries between $80,000 and $95,000. These wages are driven by high-tech industrial hubs in the semiconductor and aerospace sectors, where precision is the primary requirement. Precision machining is no longer defined by manual labor. It is now a career path for elite, highly compensated technology professionals managing digital systems. To accelerate the entry of young workers into these roles, industry leaders and the Department of Labor have overhauled traditional training programs. New tracks focus on competency rather than time served. Using platforms like NTMAU, apprentices can master 3D simulation and blueprinting on digital tablets, allowing them to advance as soon as they prove their technical proficiency. These roles allow operators to safely monitor automated cells and robotic units from a distance, focusing on system management rather than manual machine operation. Forced by trade shifts and demographic necessity, the American machine shop has become a center for automated production. It is a sector that is now more technologically integrated and more critical to national security than ever before.